Welcome to Theory of Computation class. Today I am going to explain parse tree and the construction of parse tree. In previous classes we know about the grammar notations. So grammar contains variable, terminal, production and starting symbol, and you can able to derive a string from the given grammar. That steps is called as derivation. Derivation contains two types. One is leftmost derivation and another one is rightmost derivation. So if any grammar is given, we can able to implement both LMD and RMD. So from the previous videos, we can able to construct those derivations. Now, from the derivation, how to construct a parse tree. So this is the aim or goal for today's class. So a derivation of a term is represented in a diagrammatical manner. That diagrammatical representation is called as parse tree. And these are all the conditions for construction of parse tree. If you consider tree contains a set of nodes in a hierarchical manner. So each interior node should be represented with a variable. And if you consider leaf node, that leaf node should be labeled only by a terminal symbol or it may be epsilon. So this is the second condition. If any interior node with a non-terminal letter A, then that should contain a children nodes as x1, x2, xk, where this x1, x2, xk terms are the right side of that particular non-terminal. So these are all the conditions for construction of parse tree. Let us take the same problem of derivation. Here I am taking the same example. So S implies small a, capital S, bar a. Capital A implies SBA by BA. So I want to derive an input string AA, BB, AA, and I want to construct a parse tree for this given string. So let us take the notation. So you should write the productions separately for construction of derivation and parse tree. So I am writing separately. A contain two productions, so I am writing it separately. So I want to derive AA, BB, AA. So the derivation I am taking is LMD. The starting symbol is S. So this S should be replaced as SAS. So I am writing that production. Then the first non-terminal is capital A, which will be replaced as SBA. So I am writing the production in bracket. And the first non-terminal S is replaced as small a, which is available as a second production. Now first three are same. The capital A should be replaced as BA. The remaining symbols are as it is. So A implies BA. And AA, BBA, this S should be replaced as A. So how to construct a parse tree? So always parse tree root node contains starting symbol. So I am writing the first derivation here, S. Then you check the production within the bracket. This S should be replaced as three symbols. So you draw three children. The first symbol is A. Second symbol is capital A. Third symbol is capital S. Okay, it's derived. Then, what are you doing in the second step? In the second step, A should be replaced as SPA. So, this A again splitted as SBA. So, you only draw that part only. So, you go to the fourth step. From the third step, S should be replaced as small a. So, I am writing the fourth step. Then in the fifth step, capital A should be replaced as BA. So this capital A will be splitted into two children, that is BA. Then at the last step, S is replaced as A. So wherever the non-terminals are available, here it is a parse tree. So what are the rule? The starting root node should be the starting symbol of the grammar. Interior nodes may be terminal or non-terminals. All the leaf nodes should be specified with the terminal symbol or epsilon. The interior node contains a non-terminal, means further it should be divided, or it should have a children with its right side of the production. So these rules will be followed for this notations. So in this way we can able to construct a parse tree. Then from the parse tree, how to find yield of parse tree? A string can be obtained by concatenating all the leaf nodes of a parse tree from left to right. So if you concatenate the string from left to right of a leaf node, that is called as yield of parse tree. So consider the previous example. Here it is the leaf node. This is the leaf node. This is the leaf node. This one is leaf node. This one is leaf node. This one is leaf node. So I want to merge the leaf node from left to right. So in this way, I merge these notations. So what is the first left side symbol? A. Second one is A. Third leaf node B. Fourth leaf node B. Fifth one is A. And the last one is A. So you should go from left to right. And you can able to derive an input string. So this is called as yield of parse tree. So yield is always derived from root node. What is your root node? Root node is the starting symbol of the production. Yield of parse tree can be only or always be represented with terminal symbols. So these are all the conditions for yield of parse tree. Then let us discuss a problem for yield. This is the grammar. So there are three non-terminals are available. One is S, second one is capital A, third one is B. So there are three variables are available in the given grammar. And the terminal symbols are 0, 1, epsilon. Productions are 1, 2, 3, 4, 5, 6 productions are available. The static symbol is S. Okay. So I am writing the yield of parse tree for the first notation. So I am taking the static symbol S. So this S should be replaced as A1B. So I am writing the production here, A1B. Then you take A. What is your second string? It is 1. But I want to derive the first string as 1. So what you can able to do? Instead of A, you can write it as either 0A or epsilon. If you use 0A, the first symbol will be 0, but it's not correct one. So I should use only epsilon here. So epsilon 1B. So A will be replaced as epsilon here. Epsilon is an empty string, so I leave it. The first symbol is 1, the second symbol is B. So if you take B, there are three productions are available. Either you can use 0B or 1B or epsilon. So let us take the second string. Second string should be 0. So it will be replaced as 0B. So B means 0B. So first symbol is terminal, second symbol is terminal. What is your third symbol? Third symbol should also be 0. So this B once again repeated as B implies 0B. So first three symbols are derived. Then this B will be replaced with the second production B, that is 1B. So B implies 1B. So there are four symbols are available. Then the last one should be replaced as epsilon. The remaining symbols are same. So B implies epsilon. So here the problem is prove that for the yields. So this is the derivation. From the derivation you should construct a parse tree. So parse tree starting symbol root node is S. Then it will be replaced as A, 1, B. This will be derived from second step. In the third step, A will be replaced as epsilon. In the fourth step, B will be replaced as 0B. In the fifth step, again B will be splitted as 0B. In the sixth step, B will be replaced as 1B, and in the last step, that B will be replaced as epsilon. So consider all the leaf node of the parse tree from left to right. So if I concatenating all the leaf nodes from left to right and I arrange in an left to right order, the symbol is derived. So this is the proof for the yields. In this manner, you try for the strings 00101 and 00011 for the same type of grammar. Then ambiguity means, this is the definition of ambiguity. So if a grammar is ambiguous means, you can able to derive a string W with two different parse trees. So for the same input string, if you derive two different parse trees, then that is called as ambiguous grammar. Otherwise, if you derive more than one derivations, then that particular grammar is called as ambiguity. So this will be discussed in next class. Thank you.